My name is Brendan Murphy, and I'm presenting a case study in the gaming industry for CompSci EA9 Deep Learning. So the problem that I came up with is that Game Board Geek is a very popular online board gaming community that has tons of data on over 90,000 different board games, as well as their expansions. So in this project, I want to predict whether a user rating for a board game is positive or negative, given certain attributes about the board games. And for this project, I used TensorFlow with Google Cloud's machine learning engine to create a multi-layer perceptron to do the classification. So the software that I'm using is pretty familiar to the class. I'm just using basic Python 3.6.4 with NumPy, Pandas, Matplotlib, and scikit-learn for the data pre-processing steps, and TensorFlow for the actual classification. I use a Jupyter Notebook for the data pre-processing, and then the Google Machine Learning Engine, as well as the Google Cloud SDK for doing the actual running of the application. The dataset itself can be found on Kaggle. It's 140 megabytes, and it's a SQLite database. There are 81 total features and 90,400 different board games. So most of these features are actually created by user data, like user rating, but other polling statistics and where games rank relative to other games in their class, that sort of thing. So I'm largely going to remove those features because I'm just interested in the ones that are focused on the board games themselves. So I found that board games and their expansions tend to have very similar ratings, which sort of added some noise to the data set. So I decided to just focus on board games and remove their expansions. Most of the games actually had very few ratings. So in order to sort of lend my classification a bit more credibility, I focused only on those board games that had at least 5 ratings, which this is the chunk that actually reduced my data set by the biggest. And then just as a last sanity check, I want to limit board games that were released between 1970 and this year 2018, because for some reason the year values themselves were kind of all over the place. Some had like 0, some were in the future, so I want to focus only on those that were actually published. So after doing all this processing, there were 27,940 board games remaining. Most of the remaining features were numeric, but these two that I wanted to include, board game category and board game mechanic, needed to be one-hot encoded because the values themselves were lists of strings, and those in the values were all like tags on these games. After doing some analysis, I found the average user rating was about 6. So that's why I chose 7 as my cutoff to indicate whether a game had a good rating or not, either average or not so great. For this demo, I'll be showing you how to run the board games model on Google's machine learning engine. So, assuming we have the Google Cloud Software Developer Kit already installed, the first thing we have to do is set up some environment variables that we'll need. The first is the bucket. You can call the bucket whatever you want. It just needs to be unique for across all buckets. So try to pick something descriptive. Next, we'll need the job name, which will be the identifier for the job that we'll be running on the ML engine. Next is the output path. This will be where we'll put all of the output from our tasks in our buckets. Next, we need to point to where the training data will be, as well as the data that is used for evaluation. The last thing is we'll point to the file that we will use for tuning our hyperparameters. With all that out of the way, the first thing we need to do is create the bucket. So we run this command, gsutil make bucket. You specify the region. I'm going to use US East 1. Okay, that's totally fine. Since I've been using this already, that's going to fail. So what I'm going to do is create a different one. -1. And then some of these relied on the bucket, so I'm going to redo those. Okay, so now that that's done, we successfully created the bucket. We'll want to verify that our bucket was actually created, so we can go to the Google Cloud Platform to storage, and we see that our new bucket, BM E89 Final Project 1, was successfully created in the US East 1 region. And test data into this new bucket. So I have my data in this data folder. Alright, success. We'll also want to see that our data was successfully uploaded, so we can see our data folder, as well as our train and test sets. So, now that that's done, the last thing to do is just run a job. So, this requires a bit of finagling. There's a lot of parameters, so I'll try to break it down as I go. We're going to specify that we're going to use the machine learning engine. We're going to submit a job. This is where the job name comes in. Specify where we're going to put it. All the output. We specify what task is going to be run for this job inside the module. So boardgames.task, and then we also have to point to the module itself, which it will package for us. Specify the region. I'm going to use US Central 1. Specify the scale tier. So this is a pre-established specification for if you want to do scaled instances of as opposed to just on a single instance. And standard 1. We're going to specify the configuration file that has all our hyperparameters. And then next, we're going to specify the parameters that we're actually going to pass to the task itself. So, specify the training file. The evaluation file. Number of steps we're going to use in training. And the amount of steps we use during evaluation. And I'm just going to specify that we want to see all of the output. So we're going to use debug verbosity as opposed to the default info. Okay. And scale dash here. Okay. With that done, we see that our job has been successfully submitted. So if we go to the jobs part of our machine learning engine page, we can see that our new job has started, and it's a type hyperparameter tuning. Just a small snag, I had to rename the job because my previous job actually failed because I forgot to omit to include the runtime version number that you can see here. Runtime version of the version of TensorFlow to use. So I have to specify 1.4, otherwise it uses an old version that does not have the features that I need. So if we kick this off, our task was successfully queued. Now we want to look at the result of our job. So if we go look at the logs, and search for accuracy, we see that I achieved an accuracy of 83.15%, which is noticeably higher than the baseline accuracy. So now the last thing to do is export it to a model that can be used to make predictions against. In order to create a model from our job that we can use, we go to Models, Create Model. Name it whatever you like. I'm going to use board games. And once we have that, we need to create a version for it. I'm going to name it V1. Make sure to use 1.4. And then I'll select the folder containing the exported model. Gives me a nice check. We now have a model that we can use to make predictions.